Good afternoon, everyone. On behalf of the Department of Computer Science of the Bhawanipur Education Society College, I heartily welcome all of you present today to this web talk on deep learning and computational intelligence. This event is organized by the Department of Computer Science in collaboration with the IQAC of our college. To deliver this popular lecture, we have with us today Professor Vishal Goyal. Professor Goyal is currently working in the Department of Electronics and Communication Engineering as professor at GLA Institute of Technology and Management, Mathura. He is also the Associate Director of Internal Quality Assurance Cell, IQAC, of the same university. He has completed his PhD degree in 2016 and also has published numerous research articles in well-known journals. He is engaged as a member in some high-profile organizations such as IEEE, Science Congress, ICEIT, IACSIT, and many more. Under his guidance, many students are pursuing their PhD and MTech thesis. For his immense experience and profound knowledge, we are actually delighted to invite him as a speaker in order to uplift our knowledge base in the specified domain of deep learning and computational intelligence. Today, to inaugurate our event, we were supposed to have our teacher in charge, Dr. Shuchandra Chakraborty, with us, but due to some other academic commitment, ma'am could not be here with us today. So without any further delay, I would request our eminent speaker, Professor Goyal, to start his presentation, and a request to each one of you to kindly mute your audio, and your cooperation will be highly appreciated. So looking forward to an engaging session. Over to you, sir.
Thank you, ma'am, for such a nice introduction. I'm really honored to have such a nice introduction. And let me tell you, first of all, I convey my wishes for Durga Puja to all the person available here in this web session, because it is a very popular festival in this part of the country, especially in Kolkata, because I had been to Kolkata a few times, and especially at one time I was during Durga Puja, and I have seen a lot of pandals there. Beautiful pandals are there during Durga Puja in Kolkata. But we are living with such a worse condition of pandemic of COVID-19, so we cannot go and see the pandals. In fact, yesterday only one of my friend in Kolkata shared me one pandal video. I don't know how he managed to get that video, but it was really awesome and very nice. As Madam has given my introduction, I want to add that presently I am working with Bhava Atomic Research Center. I am holding one research project of 30 lakh rupees from Bhava Atomic Research Center, and we are developing the controller for them. We are designing a deep learning based or machine learning based, you can say PD controller, fuzzy based PD controller for Bhava Atomic Research Center. So, and a new responsibility last year has been given to me by my university as an associate director IQAC. And IQAC is a very tough job to handle because a lot of work has to be done. Anyhow, anyways, now I should start with my presentation. Since all of you belongs to computer science engineering background, all of us are aware about the artificial intelligence. And after artificial intelligence, the next thing that come for our study is a machine learning. And after machine learning, the new thing comes, that is deep learning. So if you see the Google trend, if you go on Google and you see the trend on latest technologies, this deep learning is trending like anything. And Geoffrey Hinton is a pioneer in deep learning along with Andrew Ng. Both of them are the pioneer in deep learning and they are working in it. So can I share my slides so that I can, okay. Is the rights given to me to share the screen, or you have to give me the rights to share?
I think, sir, you can share the screen.
Because in my university we work on some, so that's the problem. Present now, I've clicked on present now, your present screen, video animation, entire screen. Ma'am, is there any right? Okay. Now I can see. Thank you.
Okay.
Just.
Yes, sir, we can see your screen now.
Yeah. So, is my screen visible to all of you?
Yes, sir, it is visible.
Yeah, thank you. So as you can see, I have chosen the topic for today's session is deep learning and computational intelligence. Both both are interrelated. If you can see, there are various computational intelligence tools that we use for deep learning. So that's why I have chosen this topic for today's presentation. As I told you, these are the two famous quotes from Andrew Ng and Geoffrey Hinton. Both are pioneer in deep learning. As Andrew Ng says that he has not seen such a algorithm that knocked over a benchmark like deep learning. Geoffrey Hinton says that the computational time increases because in deep learning the data set is very huge. The input data is very large, so it handles a very large data, so computational time increases, but it is still better. So both these scientists are working with Google for their self-driving car, and they are using deep learning technologies. Next, I'm moving these slides quite fast because they are just primary information which I want to pass to you to make the audience know why we are talking about deep learning. As you can see,
sir, may I just request you to enter into the full screen mode?
Okay. You cannot see me. That's why.
No, sir, we can see you. We were asking you to get the presentation in full screen.
Right. Just a minute. Now it's okay?
Yes, sir. Yes, sir. Thank you.
Yeah. So the Google, as you can see, the Google is trending from 2012. They have so much projects, software projects that uses AI technology or deep learning or very less. But it start increasing from 2013, 14, 15, and so on. So why learning is important? Learning is a very important task. Every day we go to a class and we ask a student to shift their paradigm from teaching mode to the learning mode. Means we all teachers want to shift from teaching to learning. So learning is very important. So deep learning means when the data is available, our neurons, means our brain tries to learn from the experience, past experience. So learning is very important. In this slide, it is written learning performance is an indicator of intelligence. Means how fast we learn, how fast we adapt the things is an indicator of intelligence. Now there is something called natural intelligence. We human beings have certain natural intelligence with us. Likewise, animals also have natural intelligence. Now, as you can see in this slide, they have natural intelligence. Now coming to the computational intelligence. Before coming to the computational intelligence part, let us first talk about what is a definition of deep learning. And anyone, any student or anyone who can answer this question or who can interact with me, because I want the session should be interactive. It should not be in a simplex mode, it can be in a duplex mode. or because otherwise I will pass on the slide, it will very boredom type of a thing. Anyone who is aware about deep learning or who can define deep learning, any student who can unmute and answer this question. Okay, so I should answer. I should answer. In fact, deep learning, it is a subset of machine learning. When I say it is a subset of machine learning, it means there is some correlation between machine learning and deep learning. Why deep learning come into existence? We have machine learning, we have artificial intelligence. In the beginning of my session, I already conveyed that first we started with artificial intelligence, then we go to machine learning, and then we come to deep learning. Why there is a necessity of deep learning? Deep learning uses artificial neural networks. It uses artificial neural network to train the or to create the learning environment, to train the network. So in deep learning, the data size is very huge. The input data that we provide is very large. Even the unstructured data is unstructured, or it is interconnected or undiverse, that can also learn. That data can also be handled out with the help of deep learning. The problem with the machine, if I compare the machine learning and the deep learning, if I compare these two technologies, why machine learning? In the first part of the comparison is a human intervention. In machine learning, there is a human intervention. The data size is very small as compared to the data size that we provide to deep learning. Second part is a hardware. When we go for the deep learning, since in deep learning the data size is very huge, so we require GPU, graphical processing unit. While in machine learning, we can handle the machine learning data. Since the data size is small, we can use a lower processing unit, or the normal CPU we can use instead of GPU. So hardware requirement with the deep learning is an advanced system we require, like GPU. Time. Obviously, since the data size is very large, deep learning requires more computational time. As Geoffrey Hinton in its quote itself says, the data size is high, the computational time is high, still deep learning is far, far much better than machine learning. So since the computational time is high in deep learning, while in machine learning, the computational time is less. What are the approaches? If you see the machine learning, in machine learning, what we do, we actually do the work in two different ways. Means we initially train the network in machine learning, and we then then we can identify the problem. While in deep learning, at a single go, we get the output. There are different applications in which the deep learning and the machine learning both can be applied, or both can be different. It depends. It is a debatable topic that in which area or which application the machine learning has to be applied, and in which area the deep learning is applied. Where the data size is very high, we usually apply deep learning. Where the data size is small, we prefer machine learning. So in this way, the machine learning and the deep learning can be differentiated. But as I told you, since nowadays the data size is increasing and increasing, we prefer deep learning. So in deep learning, we use one computational intelligence tool widely, that is artificial neural network. While in machine learning, we can use fuzzy logic, we can use neural network to train our network. While in deep learning, we mostly prefer artificial neural network. But these days, hybrid computational intelligence tools are used. Like deep learning fuzzy networks are used, or you can say deep learning fuzzy network with evolutionary algorithms can be used. So coming to the computational intelligence, this is a history of computational intelligence, how it has been evolved. So as you can see, first we have the ANN, artificial neural network, that evolved in 1943. Then perceptrons came, and then the evolutionary algorithm started. Optimization algorithm started, that is genetic algorithm. Then fuzzy logic came, evolutionary computing came, and like this, the things have evolved from so many years. And this is a basic definition of a computational intelligence. It is a set of biological and linguistic computational tools and methodology to address complex and challenging real-world problems to which traditional approaches may not be effective. So as I told you, the major constituents of computational intelligence are neural network, evolutionary algorithms, fuzzy system, and hybrid intelligence system. Hybrid intelligence system can be neuro-fuzzy system. On with neuro-fuzzy, we can optimize the data with the help of the evolutionary algorithms. So these computational intelligence tools are widely used to train our networks in machine learning as well as deep learning. The basic difference between machine learning and deep learning, I already told you, is the size of the data, the time it takes to train the data, the computational time. Biggest difference is the data size, and the second, because of the data size, the time requirement also changes. So these computational tools are widely used in both these technologies. Now, these are the core technologies, CI core technologies, that is neural network, fuzzy, evolutionary. And as you can see in this slide, I have shown the main components that we take: linguistic information and approximation reasoning, fuzzy logic. All these are used for the CI. Now, this is since in deep learning, as I told you, the major algorithm that we used to train our network in deep learning, it is the neural networks, artificial neural network. So it is a basic, you can say, the structure of artificial neural network of a single neuron, where you can see the weighted sum of the input they are taken, and using the activation function we are getting the output. In the lower part of this slide, how the neural network has been evolved, it is clearly given here. You can see from 1940, McLean has mimicked the human brain with the artificial neural network, and it has evolved from so many years. And in 2010, the deep neural network was proposed by Geoffrey Hinton. Geoffrey Hinton, I think he's in UK, and he's working for Google for self-driving car, both N2NG and both. And they have proposed this deep neural network in 2010. And then the world of deep neural network or deep learning came in front of the entire world. This is artificial neuron. This is a artificial neuron, and you can see the weighted sum of the input that we give, and we have the activation function, and we are getting the output. So in this way, a single neuron can be represented. It is a basic computing unit of artificial neural network. Now, this is it is a typical multi-layered neural network architecture. We have so many layers hidden. Means initially there is an input layer, then there is a hidden layer, and finally we have the output layer. The hidden layers can be more than one. In deep learning or deep neural network, if I called it as a deep neural network, the hidden layers are very large. They are not small. They are not single hidden layer. There are so many hidden layers because the data that is provided in deep neural network is huge. That's why we require a large amount of hidden layers. Now, this is a basic components of neural networks. Neurons, as I told you, you can see here there is a learning rule, and we have to estimate the weights. Now, this is the pattern of connectivity of neural network. These are all basic. If somebody is learning neural network, these are the basics which is shown in this slide. Now these are the various neural network models that we have studied from, means we usually study when we are a student of neural networks. The first one is a feed forward neural network, a single layer neural network. Then we have deep forward neural network. Hidden layers are increased, as you can see. Here is a single layer, here is more than one layers like this. Recurrent neural networks. Now, in this way, there are many architectures of neural network. There are many models of neural networks, as you can see in this. Now, there are two types of learning procedures, how to train the network. One is supervised learning and one is unsupervised learning. So in a supervised learning, we get the output. Initially, we give the initial weight, we give the weights, we give the random weights to the input layer, and finally, we get the output. Now, in the supervised learning, we are having actually the you can say estimated output is available, means estimated output is available here, and the output is given, and we compare both of them in the supervised learning, and we get the error. That error is feedback. It is given back to the networks to change the weight. Now, in this way, this process goes on. Feedback is given again and again until the error is minimized. Until the error is minimized. So in this way, the learning goes on. Means initially we give the input image. If I talk in terms of the image processing, we give the input image, and in terms of the pixels, the values are given in the input. The random weights are given in the first layer, the input layer, and the entire process continues, and we get the output. That output is you can say it is compared. It is compared with SK, and we get the error. And that error is feedback to the middle layers, so their weights are changed, and this process continues till the error is minimized. So this is supervised learning. So now there's a gradient descent method that we know very well, that we give the weights random initial values to the input, and that error that we are getting, that error we give feedback. So there is a gradient descent method with the help of which we minimize the error. We minimize this particular error. Now there is a very popular algorithm that is a backpropagation neural network. When we give feedback to error to the network, to the middle hidden layers, then that is called backpropagation. That part is called backpropagation to minimize the error. So it is again a very popular algorithm that we use in deep learning to train our network. Now, what are the limitations of neural networks? It is highly cost, means its cost is high because it is densely connected networks, and it is difficult to train with number of hidden layer increases. This is again a limitation. When it is a single hidden layer, then there is no challenge. But as I told you, in deep learning, the layers are wide. Their layers are very high. So we require more hidden layers. So it increases the cost, it increases the computational time, and sometimes is stuck in local optima. Now, what's the solution to this problem? It is deep learning. How deep learning solve these limitations, I'll tell you later on when I switch to the next presentation. Now, initially I have introduced the definition of deep learning. I have told you what are the computational intelligence tools that we use, that is fuzzy, neural, and evolutionary algorithm, and combining these two is a topic of today, deep learning and computational intelligence. Now, this is Google trend. This is Google trend, which I was sharing with you in the beginning. I told you that how the Google trend shows that deep learning and computational intelligence is increasing. As you can see, it is on the higher side these days. Now, these are some headlines which are given. There's a very reputed journal of Nature that deep learning is trending. So why I am focusing on these slides, just to make the students who are on this board to create the interest to work on deep learning networks. Now, deep learning in computer vision, since you all belongs to computer science and engineering, you know what is computer vision. So this is all image processing part. I don't think we are here to study image processing. So this is just a slide to show you that deep learning is widely used in computer vision. Now, this is another paper of deep learning on image processing. Now, deep learning can also be used in predicting poverty from satellite image. We can take the satellite image and we can train our network to predict how much poverty is there in which country or which part of the world. Again, this is a slide which is to be shown to you. Now, this here I am starting with the deep learning. As I told you in the beginning, train networks with many layers. So first line here, it is indicates train networks with many layers versus normal nets with just a couple of layers. Like in a feed-forward network, there is a single layer. In multi-layer, there are 2 or 3 layers. But in deep learning, the training is done with large number of layers. Multiple layers work to build an improved feature space. The major task of deep learning is to extract the features, because I'm taking an application of image processing in deep learning. So that's why I have written that deep learning, since large number of layers are taken in deep learning, so feature extraction part is very good when we apply deep learning. When the hidden layers are more, the feature extraction part is great. So the first layer learns first order feature, that is, for example, edges. The second layer learns higher order features. Maybe it includes a combination of edges. Some models learn in an unsupervised mode and discovers general features of input space. All these 3 points in the beginning, it totally emphasized that the feature extraction increases from first layer to the second layer to the higher layers. Every layer is extracting 1 feature, 2 features, or more features. So in this way, finally, layer of transform features are fed into the supervised layer, where we can compare and then the classification can be done. And finally, it is written, an entire network is often subsequently tuned using supervised training of the entire net using initial weighting learned in unsupervised phase. So we generally apply supervised learning using deep learning. Mostly we use that. Now this is the you can say a pictorial view how the features are extracted. As you can see, originally only few features are extracted, and since hidden layers are increasing, more and more features are extracted. And finally, here is a supervised learning, and if there is error, that is back propagated, and back propagation is applied, and the error is minimized using gradient descent algorithm. Now, what motivates Hinton and Andrew Ng for deep learning? As you know, the brain has a deep architecture. So our brain is a classical example of deep learning. When we were born, we were made to learn how to eat, how to take bath, how to sleep, how to present ourselves. From our birth, from our childhood, we are learning. Our brain is learning. So our brain is having a deep architecture. So that is the motivation for Hinton and Andrew Ng to give this world a new technology of deep learning after machine learning. Still, it is a debatable topic that machine learning is good or deep learning is good. Many researchers feel that machine learning is great. Why they feel that may be a debatable, but some people feel that since the data size is increasing, we should go for deep learning. the only problem with for the researchers, which I feel, because which I also personally feel is a bad part on deep learning, is the computational time. If you train your network with machine learning, it may be done in few hours or maybe few minutes, but in deep learning it may take few days or even a week to train a network. So it takes a lot of time. But once it is trained, the results or the feature which has extracted and the information which deep learning networks are giving, or deep neural networks are giving in the output, are wonderful. They are far much better than machine learning outputs. That's why when Google was developing, or it is in a developing stage only, I think so, to develop a self-driving car, so they apply deep learning. Hinton was a part of that particular project of self-driving car of Google. So they are applying deep learning, because when we are preparing a driverless car, we require a lot of feature to be extracted, because how at what time the car has to slow down the speed, at what time it has to increase the speed, where are the obstacle, where they have to put the brake. So a lot of feature extraction has to be done. That's why in Google self-driving car, they have not applied machine learning, rather they have applied deep learning. And you know very well, deep learning has come out from machine learning itself. Now, this is what I was talking about, the features. Automatically learning features at multiple level of abstraction allow a system to learn complex functions, mapping the input to the output directly from the data without depending completely on human crafted features. This is not possible in machine learning, because from the data itself, it is extracting the features, low level features, middle level features, then high level features, and finally we do the image classification. While in machine learning, human intervention is required. In deep learning, once it is started, you'll get the output for sure, and that is too accurate after classification. So this is given because in my every slide, in most of my slide, you will find from where I have taken the data I have cited in the bottom. You can copy and you can take this detail. So this is the increasing level of abstraction, or how the features are extracted. And finally, when we do classification, we can easily classify that in my image, which is given at the input, that this part of the image is the background image, this part is a particular object, this part is a particular human being. Like this, the classification can be done wonderfully. Why? Because at every level of the hidden layer, we are extracting the features. So there are a few points. If you want, you can note it down. As a subject, deal with a set of algorithms developed to achieve deeper intuition and interactive structures in data. Means why it is called deep. Deep means to go in deep, to extract each and every feature of the image or each and every feature of the input data. That's why it is called deep. So DL framework comprises of multiple layers of nonlinear processing mode, which are trained over a large set of data. Each layer in DL framework represents higher hierarchical level of abstraction than preceding layers. Means they extract the features, each layer. DL algorithm finds complex, meaningful pattern and structured in large scale of unlabeled data. This is another beauty of deep learning. So another point is deep learning algorithm has revolutionized representation learning in unsupervised or semi-supervised manner. Means these points I have taken from these research paper. Means maybe I have maybe not. I have taken them from the abstract. The first paper is from Geoffrey Hinton. It is a classical paper written by them when they have proposed the deep learning in 2012. So this is from their paper. As you can see, deep neural network they have proposed. These are the different structures. Deep neural network, deep belief network. These are the different configuration of deep neural network or deep learning, convolutional neural network. Now, among all these, in so many years, a lot of researchers have proposed different type of deep learning neural networks. Among all these, the most common and widely used deep learning neural network is convolutional neural network, CNN, which is widely used. So I'll be discussing that also. So again, deep learning uses several layers of nodes between input output. As you can see, these green dots, these are all hidden layers, input layer, output layer, and all these are the input layers. The series of layers between input and output identify and process features in a series of stages, just as our brain. In our brain also, it is a multiple layer, highly complex structure of neuron. Our human brain, or means it is a highly complex structure. Neurons are interconnected like this. All these nodes are interconnected, and these are all hidden layers. We have always had a good algorithm for learning the weights in the network with one hidden layers. But these algorithms are not good at learning the weights for network with more hidden layers. Means since there are a large number of hidden layers in a deep neural network, so there is a problem of learning the weights, because with the help of backpropagation algorithm, the weights are adaptively changed. The value of the weights are changing adaptively. So again, this is the history I have already told you, so no need. Now this is a very important one. Those students who have learned neural networks or those who are learning neural network, the most important part of the neural network is a backpropagation algorithm, because the weights of the neurons or the nodes which I have told you, they have to be nodes have to be their weights of all these nodes are to be adaptively changed. Why these weights are to be changed? Because we are, with the help of supervised learning, we are having an error between the input, between the output image, and you can see the ones which is given at the reference. So there is an error. To minimize that error, the weights are to be changed. With the help of backpropagation algorithm, the value of these weights changes accordingly. Now, as you can see, the name neural network DNN in 2006, and DNN is an artificial neural network with multiple hidden layers. Already told you the main idea of DNN to extract high-level features from input data. As you can see, this part of the image, we cannot see that good features are extracted. It is an input layer. This is means input layer is given, and this is a first hidden layer. Features are not extracted. In hidden layer 2, you can see the features are extracted. This is an input layer. This is an input layer. As you can see, this is an input layer where so many faces are given in a single image, and we have to extract. And this is a deep neural network. You can see such a highly complex, interconnected with large number of hidden layers. It is such a complex structure with a lot of computational time. So what's the beauty of this? That because of these so many hidden layers, the features are extracted. As you can see the faces can be recognized after passing through so many hidden layers, and finally at the output we can have the good output image. So in this way the deep neural network works. So this is again proposed training approach by Hinton. This is a proposed training approach given by Hinton. It is pre-trained first hidden layer. As you can see that this is the first hidden layer. Then they have passed feature is extracted, then in this way the layers are increasing, the hidden layers are increasing, and at the output it is done. Train first layer using data without the label, unsupervised learning. The first layer is trained. This is proposed by Hinton. Then freeze the first layer parameter and start training the second layer using the output of the first layer in an unsupervised manner. In this way, means this is the approach that Hinton has used and we apply in the deep neural network. We train the first layer, then the output of the first layer is given to the input of the second layer to train the second layer in an unsupervised manner, then to the third layer, and in this way it is propagated and the features are extracted. Now, this is the thing which I was talking about from last few minutes. Input, features, more abstract features, even more abstract features. Like this, it propagates. And finally, the classification is done. This way it is approaching from bottom to top. Input, features, more features. Like this, it is moving. Now, these are the deep neural network architectures. Till now, means I have taken from Wikipedia, and maybe some because I have prepared this presentation a few months back, maybe some have been added up. So these are the different one, and this second one, convolutional neural network, it is widely used. That I will be taking on in few minutes. Now these are the most widely used deep neural network architectures. Convolutional deep stack autoencoders like this. So I'll not be discussing all these because as I told you, I'll be discussing more on this convolutional neural network, right? So before should I start with the convolutional neural network first, then I come to the evolutionary algorithms? It will be okay?
Okay, sir, no problem.
Yeah. Just okay. Is the slide visible?
Yes, sir, it is visible.
Yeah, as you can see, this is a definition of, these are just the images. Suppose this is an image available to you and you have to extract the features. The one way is to that in this particular, we apply artificial neural network, a normal multi-layer feed-forward neural network. We can apply and we can extract the feature, but that result will not be great. So we apply convolutional neural network. So this is what we do in CNN. Can anybody tell me what is the meaning of convolution? Convolution. Let me tell you, because in order to understand convolutional neural network, it is very important to understand the meaning of convolution. We know, do you know what is a system? The system, any discrete time system or any system, it is a black box. Any system means, what I can say, it is a computer, it is a system. So we give the input to the system and we get the output to the system. A classical definition of a system is, there is a system in which we give input and we are getting the output. So how we are getting the output of the system means, the system function will be there. There might be a certain definition of the system. How I'll define you, because you are not a people of electronics and communication, so it is difficult for you. If I take the electronics example, okay, let me take an example of a mobile phone, because these days everyone are having a mobile phone. When we call to us a particular person, we dial the number. So that is an input that we are giving to a mobile phone. and in the output, what is happening? We are listening to a person whom we are calling. So the mobile phone is a system. So in order to hear that particular voice of a person to whom I am calling, what we are doing? We are giving input number. That input number is multiplied with the system function, that it is given to the system, it is multiplied, it is convolved with the system function, and finally we are getting. If you want, you can write, suppose X is the input. Suppose X is the input and H is a system function. X is the input, small h is a system function. So in order to get the output Y, we can get the output Y when X is convolved with H. Or you, since you are computer science people, you can understand, when X is multiplied with H, we are getting Y, the output of the system. So with the help of convolution, we are getting the output of the system, right? So this is the meaning of convolution. So here in convolution neural networks, we are giving this input image of a cat. Now, as you can see, we are extracting the features. As you can see, these are the lines, these are the pixel values. We are taking these pixel values, this entire pixel value, this is the input. This is the input to a computer. Now, this is multiplied with what? With a filter, or you can say with a filter or a maskable filter. Now, what will happen? You will get the output. Output is a feature. So like this, we get the features. So convolution means we are multiplying the image with a filter and we are getting the output. Now, steps in CNN. As you can see, this is a convolution we are doing. Here we are doing the convolution. This is the input image. We are multiplying it with a filter, maybe 3 by 3, maybe 9 by 9, or 12 by 12. And we extract the features. As you can see, the number of features that we are extracting are increasing like this. These are the hidden layers. And then finally, we do full connection, means they are fully connected. All the features are fully connected, or you can say the classification is done. So entire image classification is done, that which features are giving me the image of a dog or a cat or a lion or a bird. So entire features are classified. Now this I was talking about, this is an input image and this is feature detector, or we call it as a filter. Now both of them are convolved. Both of them are convolved to give me a feature like this, which I was talking about. So this is multiplied, as you can see here, it is multiplied and it is giving me 0 value. This is a feature map. The first feature, the first pixel value of that feature I am extracting from the first hidden layer. This is called convolution. As you can see inside the circle, a cross is there. It is a convolution of the input image with a filter, which I was talking about. This is an input, this is a mobile phone, and this is a voice you are hearing. This is what I'm trying to correlate. Convolution gives the output of the system. Convolution gives the output of the system when the input and the system functions are convolved. So here the input image and this feature detector are convolved, and we are getting a first feature in the feature map. Like this, we are having multiple hidden layers, and these are called convolutional layers. So every layer is giving me one feature. Every layer is giving me low level feature, then high level. Like this, the level of the features we are extracting. But the computational complexity increases. It is on the higher side. Why? Because the hidden layers, like this, we create many features map to obtain our first convolutional layer. Now you can find from this website, there are a lot of different kinds of filters and kernels in image processing. If you can note it down. A lot of image kernels are given here. Filters are given on for the convolutional neural network. So we do pooling, right? So it is flattening of the image. Finally, in this way, we do the flattening, means we extract the features, pooling of the layers, and finally, we are getting this. So finally, the classification is done in the end. Here, we are getting a classification. Now, all these features are coming here, they're combining here, and it is a first, it is dog or a cat. So this is about the, you can say, about the, let me share you the evolutionary algorithm. It is visible, evolutionary algorithm.
Sir, your screen is visible.
Yeah, thank you. So this is the thing which I love the most, evolutionary algorithm. Actually, we electronics and communication people are using particle sum optimization and different optimization techniques the most as one of the computational intelligence tool, because it optimizes the data to the fullest. So the most famous one is the particle swarm optimization. So it is some sort of bio. There means particle swarm optimization. If you can, in short, please, you can read the study of the design of intelligent agents. Uh, have you seen how the if you put a sugar cube at in your home, you will find that there is a particular pattern of ants they are following to reach that sugar cube. Have you seen the group of birds flocking in the air? Have you seen the movement of ducks in a pond? Have you seen how the fish, the group of fish move in the sea in a particular pattern? So all these are the intelligence, means this is the intelligence. As you can see, the agent is something that acts in an environment. Agent include worm, dogs, thermostat, airplane, human, organization, society. So all these evolutionary algorithms are bio-inspired algorithms. They are bio-inspired algorithm as well as meta-heuristic algorithms. So basically, they are used. They are used to optimize the data. When we do any experimental work, we have a large data size available at the output. Then what is optimized data? How to get the optimized data? The first evolutionary algorithm that came into existence was a genetic algorithm, GA. Then a lot of algorithms came into existence. These days, there are more than 1,000 evolutionary algorithms that are present here. So these are the, as you can see here, it is written agents in the world. These are the CI agent, computational intelligence agent. So the swarm intelligence, as I told you, the most commonly used in the entire world. So based on the swarm intelligence, we have particle swarm intelligence, we have spider monkey optimization, we have artificial bee, ant colony. A lot of other names are given to these. A lot of evolutionary algorithms are present in this entire world. The spider monkey algorithm, monkey optimization algorithm, is developed by one of my very good friend who is working in South Asian University in New Delhi, Dr. JC Bansal. He has developed this spider monkey optimization algorithm. Now, what is swarm intelligence? As you can see, the emergent collective intelligence of group of single agent. This is, and the examples are group of aging of social insect, cooperative transportation, division of labor, nest building of social insects, collective sorting and clustering. In simple words, if I give you an example of swarm intelligence, like birds which are flocking, or you can say the ducks which are moving in a particular pattern, the ants which are moving, all these are the these are the swarm intelligence. So I think it requires another half an hour for me to go to the PSO. As you can see, I was talking about this birds flocking. So the idea behind PSO, particle swarm optimization, is the idea of to simulate the bird's behavior in finding food through social learning, because they have to find the shortest path. So using using particle swarm optimization also, what we are doing, we want to reach to the optimized value of the data. That's why here also the birds also, with the help of social learning, they are finding the shortest path like this. So it is again a lengthy topic. I'm not taking presently. Okay, is this okay? Yeah.
Sir, is that all from you?
Yeah, because
Oh,
particle swarm optimization, again, it requires half an hour more, 45 minutes more.
okay, sir. Uh, thank you so much, sir, for such an enlightening lecture. And I think all the students and all the other participants, because we do have students as well as we have teachers from other colleges as well. And I believe that this lecture was useful, helpful to all of us. With this, I would request Mr. Shonji Bhaldar, head of the Department of Computer Science of our college, to present the vote of thanks to our eminent speaker. Over to you, sir.
Thank you, Runa. Distinguished guests, dear colleagues, beloved students and other participants. It is my privilege to have been asked to propose a vote of thanks on this occasion. The lecture has been very intensive, productive, and fruitful. All of us have been enlightened by the expert knowledge of our esteemed speaker, Dr. Vishal Goyal. On behalf of the Bhawanipur Education Society College, I extend a very hearty vote of thanks to Dr. Vishal Goyal for sharing his thoughts and opinions with us. I would like to express my sincere thanks to Dr. Suchandra Chakraborty, teacher in charge, and Sri Tathagato Sen, IQAC coordinator of our college, for their encouragement and cooperation to organize this event. I would like to take this opportunity to place on record our heartfelt gratitude to the management of our college for their perfect logistic support, guidance, and enormous cooperation in organizing this event. Last but not the least, and an event like this cannot happen overnight. The wheels start rolling weeks ago. It requires planning, perseverance, and meticulous detailing. I have been very fortunate to be backed by a team of very motivated and dedicated colleagues of the department who know their job well and are result-oriented. I am thankful to them for their unconditional support. The end of a story is the new beginning for many others. On behalf of the Department of Computer Science, we sincerely promise you that in future we will keep on organizing such academic events with innovative ideas to nourish your mind and fill you with more knowledge. Thank you. Thank you so much.
Thank you, sir.
Now, thank you. Now I would like to request Shawnee Dotto, the convener of the event, to conclude the session. Over to Shawnee.
Thank you, sir. Thank you, our speaker. And we have, sir, one question from Rohit Sharma. Can you please say into that? Sir, does max schooling works on color pictures also? Rohit Sharma has this question. It would be a great pleasure that if you answered this question.
Yeah, it can work.
Okay, Rohit, I believe you have got your answer. And finally, what can I say is, see, deep learning and computational intelligence are obviously interesting fields in data science. And in the current era, it is evident to acquire knowledge on these currently trending fields. It is a well-known fact that artificial intelligence has gained immense popularity in various domains, thus making automated process in a reality. Deep learning is even an expertise portion of AI that gives insight of future progress of this automation. These concepts are clearly elaborated by our speaker, sir, and I am really thankful to him. These concepts will also be beneficial for the students as well as the researchers for pursuing their further studies. I wish you all the very best for your future work. This is all from my end.
Sir, do you have, Vishal sir, I would request you if you have anything to share with us, with the participants, if you want to say something.
Yeah, because I believe that many students are also here in this session. Is it?
Yes. Yes, sir. Yes, sir.
Yeah. What I want to convey that since you are a computer science engineering students, and there is a lot of opportunity in front of you. In my university, we have the maximum intake of computer science engineering. And these days, a lot of technological changes are coming in every field. So multidisciplinary approach is required. So in our university, what we have done is we make the project group of electronics, computer science, mechanical student combined, so that the multidisciplinary project can be made and it can be presented. Rather than there is one approach. Traditional approach is you make the project of 4 students of computer science. Like this, we make the project group. But we have changed in 1 or 2 years. We are making a multidisciplinary group of students so that they can do the project. The second thing is project-based learning, PBL. PBL is very important, project-based learning, because this pandemic has made all of us learn that classroom teaching is not sufficient. It is means not only the way of learning. The students have to come out and have to learn. There are many technologies available. What I feel, what I talk to my student in this pandemic situation, since all of you are taking online classes, there is a lot of time available to you at your home. So why don't you do different type of certifications? There are a lot of certifications available on Agile or different technologies. Because we have a good every recruitment company, whether it is Microsoft or any good companies, all these companies are looking for new technologies. And if you learn the new certification or new things, and now because of online environment, you can take good certification at your home. So this will help you a lot. This is what I want to convey. In my university, we have around 4,000 computer science students. We have around 12,000 students in our university. We have around 600 faculty members, and we have engineering, masters, MTech, PhD, management, MCA. And let me tell you one fact, sir, Sanjeev sir. One of my cousin is passed out from your college 20 years back. So I was talking
nice to hear you that. Nice to hear you that.
and their kids are in, I think, 11th standard. And when I told them I am going to one college, Bhawanipur, they told me that they are your alumni. And I was really very happy that I'm giving a lecture in your college.
Sir, convey our best wishes for him.
Yeah, definitely. And they praise a lot. They told me that that St. Xavier's and Bhawanipur are the two only colleges that are in Kolkata. Famous colleges in Kolkata. They told me like this, because I was unaware, because there is a lot of cultural gap between this part of the country and Kolkata. There is a lot of cultural gap also. So I request all the students, if you have any query, I'll be in the chat option. I'll be sharing my email ID. You can talk to me. There is a lot of opening for you. I was seeing, I was, yes, means 3 days back, Accenture was there in my university for campus recruitment. So I was talking to the Accenture people, means online only the campus recruitment is going on. So I was talking to them. This year, the hiring will be much higher, like than previous year for computer science graduate. This year, the hiring will be much higher than last year, because these software companies have saved a lot of money because of this online mode, because their employees are working from home, office is not open, electricity bill, this transport, all money they are saving like anything. So they are hiring, they are getting good projects. So a lot of companies are available, but only those the companies, what they want the skilled computer science engineer. They don't want coder only. There are a lot of technology. So multidisciplinary things are required the more. Like IoT. We have IoT in our university. We have IoT. We have this, what you can say, cloud computing courses. I mean, different branches of computer science are there. In specialization with IoT, in specialization with big data, in specialization with cloud computing, like this. In computer science, only there are 6-7 departments inside the computer science. So what I feel, the electronics, computer science, mechanical can form a group and work on a project. This will help you a lot. And please, all students publish research papers, because undergraduate students don't focus on publishing the paper. Please publish it, put a lot of weight. 10 days back, Capgemini was there for the campus recruitment, and 2 of my electronics students were selected because of their publication in SCI journal. They have paper published in graduate level, in BTech level, they have published 2 SCI paper, and they were taken by Capgemini like anything. So this will help you, your university, your faculty a lot. It will bring laurels to your university if you write research paper. Because if you not write research paper, your good work is not validated. Your good work is validated only if you publish in good journals. And you have good guidance from Sanjeev sir, Tawny ma'am, all other ma'ams are, all sirs are with you. You take the idea, write a research paper and publish them, right? And if you come to this part of the country, you are welcome to my university. It is located on NH2, Delhi Metro Highway. It is in the place of Krishna. And that's all from my side, sir. Thank you.
Thank you so much, sir. Thank you. Sir, if you can kindly share your mail ID in the chat box.
Yeah.
So do we have any more questions from the student side or from any participant? If not, then I believe that we can conclude today's event. And once again, my deep thanks to you, sir, for such a view. Shoman Roy has written, what is autoencoder?
Showman Roy, actually, autoencoder is a type of deep neural network only. It requires another session to explain you autoencoder. It is a type of a deep neural network only, and it has a different type of a structure. So, what I'll do, I'll share my slides to Shawnee ma'am. I'll send you my slides, and I'll send you more data. Actually, let me tell you, I am working closely with Professor Nishal Verma, IIT Kanpur. He's my mentor. So we have a research group. It comprises of a few professors from Kolkata only. If from your city only, I know a few good professors. My vice chancellor is also from Kolkata, Professor Falguni Gupta. You might be knowing him. Professor Falguni Gupta, he was previously the director of NITTR Kolkata. So after he was a professor in IIT Kanpur, then IITTR Kolkata, then he joined my university in June 2020. So Professor Falguni Gupta is here, and Professor Nishal Verma, IIT Kanpur, who is pioneer in deep learning. If you'll ask me, I can arrange a lecture of his to your college. He's you can say he's a master player in deep learning in IIT Kanpur. He has a lot of projects and he's working in deep learning. So autoencoder require another 1 hour or 1.5 hours to explain you autoencoders. So it required time spent.
Okay, so I request Showman Roy to contact Sir personally after the event if you want, as Sir has provided his mail ID. And also, when Shawnee ma'am gets the material here, she will surely send across the mail. Okay, so if not there is any further queries from anyone, so I'll happily conclude today's event with again deep thanks from my end and to all the teachers of the Department of Computer Science.
Thank you, ma'am. Thank you. Thank you very much.